So today we're going to look at combining two things that we've learned. We, over the last couple weeks, have done parametric equations and we've done conic sections, and now we're going to put the two together. So on page 131, I'm actually going to start with example number 2. So I'm going to start with number 2, and it says that I have x squared plus y squared minus 6x plus 8y plus 9 equals 0. So if you look at ax squared plus b y squared dot 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 dot, you can see that right here the a is 1 and the b is 1. And since a equals b, this is going to be a circle. And I want to prove that by completing the square. So I'm going to rewrite x squared minus 6x plus a blank plus y squared plus 8y plus a blank equals a negative 9. I'm going to move that 9 over to the other side. In my first blank, I'm going to do b over 2 squared. So negative 6 over 2 is negative 3. Negative 3 squared is a 9. And if I add a 9 on the one side, I have to add a 9 on the other side. Do the same thing for the y stuff. B over 2 squared. So 8 over 2 is 4. 4 squared is 16. Plus 16. So now this factors into x minus 3 squared plus y plus 4 squared equals, these 9s cancel out, it equals 16. So here I have a circle, and its center is going to be 3, negative 4, and its radius is 4 because the square root of 16 is 4. This up here when we started, this was called general form, general rectangular. This is called standard form of a circle. And now we're going to take it from standard to parametric. So move this down a little bit. So a long, long time ago, you learned about this equation that said sine, not sine, sorry. It said cosine squared theta plus sine squared theta equals 1. Well, this was the equation of the unit circle. And so I'm going to combine these two equations. And so the first thing I'm going to deal with is that I need this to equal 1. So I'm going to divide 16 over. So I'm going to have x minus 3 squared over 16 plus y plus 4 squared over 16 equals 1. And now I can match up these pieces. These pieces go together, and these two pieces go together. So I'm going to solve in my first square right here. I'm going to solve for x. So what I'm going to do is I'm going to multiply this 16 over. I'm going to set these two things equal. So I'm going to have cosine squared theta equals x minus 3 squared over 16. So I'm going to multiply this 16 over. I'm going to square root both sides. So the square root of 16 is 4, and then the square root of cosine squared is just cosine theta. And then I'm going to add the 3 over. So 4 cosine theta plus 3 equals x. There's the x part of my parametric equation. I'm going to do the same thing for my y stuff. So I'm going to multiply that 16 over. So sine squared theta equals y plus 4 squared over 16. 16 sine squared theta equals y plus 4 squared. Square root both sides. So you get 4 sine theta equals y plus 4. And so 4 sine theta minus 4 equals y. So these two things that I'm circling in green, those are your two final answers. So let me shrink this way down really quick. So if I'm looking at page 131, it says letter A. It wants me to write the parametric equation. So I did that. 4 cosine theta plus 3 equals x, and 4 sine theta minus 4 equals y. B says write the equation in standard form. We did that up here above. We had x minus 3 squared plus y plus 4 squared equals 16. And then it says it wants us to sketch a graph. So to sketch my graph, my center is going to be 3, -4. So 1, 2, 3, 1, 2, 3, 4. And then from there, my radius is the square root of 16, which is 4. So I'm going to go up 4, over 4, down 4, over 4. And I am not the world's best drawer, but there's your parametric equation. And this would have had arrows on it like this because the cosine was the x stuff, so we know that this thing moved counterclockwise like my unit circle does. So now let's go backwards. Let's go back and do number 1. So number 1 is the other way around. Number 1 says x equals 6 cosine t. And then it says y equals 6 sine t minus 4. So this one gave me the parametric, and I need to go back to the rectangular. So I'm going to divide the 6 over. So x over 6 equals cosine t. And then I'm going to square both sides. So you're going to get that x squared over 36 equals cosine squared t or theta, whatever you want to call it. On the y stuff, you need to add the 4 over first. So you're going to have y plus 4 equals 6 sine t. I'm going to divide by the 6. So y plus 4 over 6 equals sine t. And then again, got to square both sides. So I'm going to have y plus 4 squared over 36 equals sine squared t. So here's my cosine squared plus, actually, let me do this in color here. Here's my cosine squared right here plus my sine squared stuff. And that's going to equal 1. But instead of writing cosine squared, I can write x squared over 36 plus y plus 4 squared over 36 equals 1. And since we can tell this is a circle because the denominators are the same, I can multiply the 36 over and get x squared plus y plus 4 squared equals 36. So we can now tell this is a circle. This is what you would write on the line for line B. Oops. And then it says it wants us on line C to write it in general form. So general form is where it equals 0, it's all multiplied out. So my x squared is going to be left alone. I'm going to FOIL this piece out. So when you do that, you get y squared plus 8y plus 16. I'm going to minus the 36 over so it equals 0. X squared plus y squared plus 8y minus 20 equals 0. This is the answer for line C. And then line D says it wants us to draw a graph. So I'm just going to sketch a graph to the best of my ability. So on this one, I'm using this right here. My center was 0, -4. And my radius was, actually I'm using this one. My radius is 6 because the square root of 36 is 6. So from there, I'm going to go up 6, down 6, over 6, and over 6. So again, you're going to give a pretty circle. And don't forget your arrows. Okay, so now we're going to go on. And let's go do problems 3 and 4. Okay, so to do problems 3 and 4 on page 132, we need to go back and remember our Pythags. We have a Pythag that says secant squared theta minus tangent squared theta equals 1. And this is the one we use when we have I hyperbola. On the previous 2 pages, we used cosine squared theta plus sine squared theta equals 1 for circles and ellipse. So let's start on number 3. Number 3 says that I have 4 secant t minus 3 equals x. So I need to solve for this secant t, so I'm going to add the 3. Then we're going to divide by the 4. Secant t equals, and then we have to square both sides because we need to say secant squared. So secant squared t equals x plus 3 squared over 16. So this is important. I'm going to do the same thing with the y stuff. So it says y equals 6 tangent t plus 5. I'm going to minus the 5 and divide by the 6. So you're going to get y minus 5 over 6 equals tangent t. I need tangent squared. So I'm going to square everything. So tangent squared t is going to equal y, oops, it's a minus, sorry. Y minus 5 squared over 36, because when you divide the 6 over and then square it, it's 36. Here's my other important one. So that Pythag said secant squared t minus tangent squared t equals 1. So since my x stuff has the secant, my x stuff is going to come first. So you're going to have x plus 3 squared over 16. I replaced this with this into there. Minus, I'm going to take this, which is this, and I'm going to replace it into here. So I'm going to have y minus 5 squared over 36 equals 1. So here is what you would write on line B. That's your standard form. So I'm trying to move all of it, but it doesn't want to go. So now I'm going to have to FOIL out. So to FOIL this out, the first thing you have to do is we're going to have to multiply this whole thing by the LCM, the least common multiple of 16 and 36. So you can use a calculator to do this. You could multiply by 16 and 36, but it might be too big. So let's see if they have a smaller common multiple. So on your TI graphing calculator, if you go to a new calculator page and do menu, number, and then the one that says least common multiple, and do 16, and then you have to put a comma, 36. It'll tell you what the smallest number that they both go into is. I'm just checking. So the smallest thing that 16 and 36 go into is 144. So I'm going to multiply this whole equation by 144. So you're going to get x plus 3 squared, and then 144 divided by 16 is going to be the 9 out front, minus 144 divided by 36 is going to be 4. X minus 5 squared equals, and the 1 times 144 makes 144. And now I'm going to multiply this all out. So here we go. So 9 times x squared plus 6x plus 9 minus 4 times y squared minus 10y plus 25 equals 144. Got to multiply that 9 in. So you're going to 9x squared plus 54x plus 81. I'm going to multiply the negative and the 4 in. So it's going to be minus 4y squared plus 40y minus 100 equals 144. And now I'm going to rewrite this in combined like terms and minus the 144 over. So 9x squared minus 4y squared plus 54x plus 40y. And then I'm going to do 81 in my calculator minus 100 minus 144, because you have to move the 144 over, so it's negative 163 equals 1. This is the answer that goes in line C. The last thing we have to do is we have to put this into a graph. So let me just shrink everything down really quick. Here we go. I finally got a hold of everything at once. So let's add a graph in. So I'm going to go back up and use this equation that I had right here. The x plus 3 squared over 16 minus y minus 5 squared over 36 equals 1. The center should be negative 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. My a, since x is first, this is going to be a sideways hyperbola. So my a value is 4. So 1, 2, 3, 4. 1, 2, 3, 4. My b value is 6. And then I'm going to be way off the graph up here. So I'm going to guesstimate. So there's that box you would have. Let me switch colors really quick. I'm going to do some purple. Remember, your asymptotes would go through the center of the boxes and through the center that you drew. This right here and this right here were my two vertices. So your hyperbola would have done this. Now keep in mind, because the x stuff had the secant, I know it went side to side. But if the y stuff has the secant, then it's going to go up and down. So let's do number 4. So number 4, we're going to go the other way. So we're going to have 25y squared. I'm going to put it in order when I write it. Minus 50y minus 9x squared minus 54x. And I'm going to move it over. Equals 281. I'm going to move the 281 over. And so you're going to have a plus blank and a plus blank. But we can't fill those blanks until we pull these numbers out. So I've got to pull a 25 out. So I get 25y squared minus 2y plus my blank minus 9. Now you've pulled out a negative 9, so be careful. X squared plus 6x plus blank equals this 281. So the opposite of b is going to be 2. 2 divided by 2 is 1. And then 1 squared is 1. But you really added plus 25 because you have to bounce. Negative b, so negative 6 divided by 2 is 3. 3 squared is 9. You're multiplying by a negative 9, so minus 81. So now I'm going to have 25y minus 1 squared minus 9x plus 3 squared equals 225. You got to divide everything by 225. So you have y minus 1 squared over 9. 25 over 225 reduces to 1/9 minus x plus 3 squared over 25. 9 over 225 is 25 equals 1. So this is the answer that would have gone on line B. For line C, this we go secant squared theta minus tan squared theta equals 1. So we're pairing things up. So these two go together. These are going to go together. So when I solve for my secant, I'm going to multiply the 9 over. So 9 secant squared theta equals y minus 1 squared. So then square root 3 secant theta equals y minus 1. So y is going to equal 3 secant theta plus 1. There's one of your parametric equations right there. The other one, you're going to do 25 tangent squared theta equals x plus 3 squared, square root both sides, so 5 tangent theta equals x plus 3, and you're going to minus the 3 over. So x is going to equal 5 tangent theta minus 3. So there's your two parametric equations. This would be the answer that you wrote on line C. And the last thing says we have to graph it. So I'm going to use this version right here. And so this time it's going to be up and down, and my center would have been 1, negative 3. I'm going to go up and down 3 for my two vertices, and sideways 5. Draw that dotted box. So my asymptotes go through the corners of my boxes and through that center I drew. And then they're going to hug those asymptotes. So these yellow things that I'm drawing in a solid yellow line are my branches of my hyperbola. So there's number 4. So now that you can do this, you can go back to Canvas and you'll be able to complete your work.